This is the Building Automation Monthly Podcast with Phil Zito, episode 102. Hey folks, Phil Zito here, and welcome to episode 102 of the Building Automation Monthly Podcast. And in this episode, I'm going to be presenting to you the same presentation I did at the ASHRAE Expo on Building Automation Systems 101. And I'm going to be doing that courtesy of the recording that I managed to get while I was at the expo. So you're going to be able to hear the exact same presentation that filled a room of 200 people, and those who couldn't sit in that room were standing. So it was about 225 people in that room. So very well attended presentation, got a lot of great feedback from it, and you're going to be hearing it here on the podcast. Now, for those of you who want to actually view the presentation and who want to have the workbook that I created as part of the presentation, I've got you covered. I will have that on my website where you'll be able to access the links to access the video as well as download the workshop. And that'll be at buildingautomationmonthly.com/102. So without further ado, let's dive into the presentation.
Okay. So it's 11 o'clock. So we're going to do a quick exercise. Everyone put up your left hand. Left hand. So everyone here can raise their hand. We've seen that. There's proof. So when I ask questions, there will be hands in the air. You guys unwittingly committed to answering questions. All right. I'm Phil Zito. I'm going to be taking you through Building Automation 101, the primer you never knew you needed. And if you're expecting something else, then right now would be the time to leave, not in the middle of the presentation. Okay. So, wow, that went really fast. There we go. So I'm going to take us back in time. So it's 2007, January 23rd. I just got out of the U.S. Navy. And I'm given the opportunity to work at a glass factory, a soap factory, or to work in building automation. Now, I still feel like I missed out on reinventing Palmolive, but the fact is I chose building automation. I hopped on Wikipedia, studied enough to pass my interview, and then consequently got let go right after this picture because I didn't know what I was doing. So, yes, but I'm still in building automation, so I was able to work things out. I spent the next 5 years spending every night studying building automation. The Honeywell Gray Manual and I became great narcoleptic buddies. I would fall asleep with it on my head and somehow it made its way into my brain. Well, what happened from there is after doing all that studying, I ended up at Johnson Controls, and this is a picture of me the day I resigned from Johnson Controls and started my own BAS training business. And what I learned during that time is that there's actually 3 principles. Out of all the stuff I've learned, there's 3 principles to building automation that if you get these principles, it will serve as a foundation throughout your career and will really help you build on all the other building automation industry knowledge that is out there. Because let's be honest, there's so much that is just slamming at you every day. There's just too much to take in. And if you don't have a solid foundation, you're not going to be able to understand what's coming at you. So throughout this presentation, you've all got a workbook in your hands right there. And it's really simple. All you got to do is fill in the bolded words on the slides. So I've made it super easy. There's no shenanigans. It's just, there's going to be bolded words. Fill them in. But you're going to want to pay attention because there's a rumor that there's some really good milk chocolate on this table for people who can answer questions. And then there's going to be a bonus lightning round where you can actually get a book that I've written and you can win that at the end of the presentation. So we're going to want to pay attention. All right, so like I said, I discovered these 3 principles. But before we go there, we should probably cover the main topic of the presentation, what a building automation system is. So I found this very cryptic definition in the Honeywell Gray Manual. I'm going to make a slight adjustment real quick. Look at that. I can work as an AV person, maybe. Here we go. So a building automation system provides the automatic centralized control of a building's heating, ventilation, air, lighting, and other systems. Does that sound accurate? Do you guys agree? I don't agree. I see so many building automation systems that, I mean, if you ask them to tie into a Lutron system, they'd probably explode. So I don't like that definition. And this dog doesn't like that definition either. So what is a BAS? Well, a building automation system, as I see it, allows an operator to monitor, this is where you start filling stuff in, adjust, and report on the status of a control system. And it's really important we understand that right there, because there's so many other things folks try to do with their building automation systems, but they don't even get this stuff right. That's why we see 50,000 unacknowledged alarms. That's why we see unbound references on graphics that make no sense. They've got pictures of other buildings in other countries on them. I've literally seen that. And if we don't get this right, how in the heck are we going to do analytics? How are we going to do fault detection? How are we going to do all this real cool stuff that you're going to see out there on the floor without a solid foundational system in place? So, principle number 1, and you're going to want to memorize these. I'm going to tell you that you're going to get a question on each of the principles. So I just told you that. So when it comes, don't be surprised. Okay, a BAS is not a control system. Now, what is a control system? It processes inputs to drive outputs. And for the longest time, I was one of those people who acted like they knew what they were talking about. And I'd go out there and be like, oh yeah, the pneumatics and the DDC, and I had no clue what a DDC system was. But by the end of this real quick section here, you will. So a control system processes inputs to drive outputs. Now, there are 3 types of control systems. Pneumatics, so that's a control system that uses compressed air to drive actuators, and basically, you've got main high pressure air, and it goes through a device that senses, what temperature it is, and then takes that air, lowers the pressure, and uses it, called control air, to then drive some sort of device, typically actuators, maybe sometimes solenoids, things like that. Then you have electromechanical controls. This is the controller that I unfortunately have in my basement still, since I have a heat pump and I've yet to find a good smart home thermostat that works with multi-zone heat pumps with radiant floor. So if any of you know that, come to me afterwards. I'd love to know that. My wife would love if I put a smart thermostat in. And then direct digital controls. And this is a control system that uses microprocessor controls. So what do these look like? Well, before we do that, we should talk about the key point. So most designs focus on control systems. How many times have you seen a specification that spends 10 pages on, 4 to 20 milliamp, 10K platinum sensors, and then spends 2 sentences on the graphical user interface? I mean, and then folks are like, why did we not get graphics? Why does everything look different? Well, because you didn't specify any of it. You spent 10 pages on the thermostat, though, so that thing's going to be rock solid. All right, so we need to realize that control systems, they do need to be specified, but they are not building automation systems, and you'll see why in just a second. Okay, so pneumatics, if you haven't seen them before, pneumatics use compressed air to measure inputs and control outputs. This is a globe valve, if I remember correctly, and you can see there's a pneumatic bladder in there that essentially drives this little thingy-mabobber down and causes the valve inside there to move, thus water flows. How am I sounding so far? It's good? Yeah? Awesome. Electromechanical controls. I'm sure everyone's seen one of these things. So right here, you basically have a wound up temperature and it expands, it's a piece of metal, expands, makes a relay contact, then drives outputs, drives fans. This is that old WG, someone help me here. What are the names of the outputs that come off an electromechanical thermostat? There's W for fan, R, Y. You guys, speak. Come on. I don't memorize this stuff. I've got Google. All right, thanks. And that's something, you guys live in the best time ever because you don't have to memorize everything anymore. You could seriously just have your phone under the desk during the meeting and just type in, what does that part mean? And then folks think you're a genius because you're like, oh yeah, I know what that part means. It's this. So that's just a little trick for you right there. Direct digital control. We're going to spend a little time on here because this is something I didn't know for the longest time. And I thought I knew it, and I sounded kind of dumb because I was talking, but I really didn't know what I was talking about. So direct digital controls, the reason these are a big deal, and I always wondered why are these a big deal? Because in the past, those pneumatics, the electromechanical, they were all analog, meaning they processed resistance, they processed voltage, things like that. The direct digital control, what it did was it allowed you to take an analog input, so maybe a resistance value, and convert that to ones and zeros. Now that becomes a big deal because what do computers speak in? If any of you have kids, you may have seen the Teen Titans episode where they go and they program binary for 30 minutes. It's actually really boring, so don't watch it. But they talk about binary. And so binary is 1 means on, 0 means off. And now that you have the ability to take analog, so resistance, and turn it into a binary signal, the computer inside of this thingy can then go and make decisions. That's how you're able to put programs inside field controllers. That was a huge deal because now you could make things digital, you could write custom programs, and then you could eventually take them to a networked state where you could then send them up to the IP network and have visualization, have scheduling, have alarming, trending. All of that was dependent on us getting these inputs and outputs into digital format. So if anyone ever, you want to win a beer or something, ask someone what DDC is and bet them that you know and they don't, and you can win a beer. All right, so key point, if you try to solve BAS problems with your control system, you're not going to solve your problem. Okay, so this is the first question. So you got to be quick with your hands here, all right? So whoever wants to answer this question, raise your hand. The first hand I see, I will call that person out. Without looking at your paper, what are the 3 types of control systems? Oh, okay. All right, come on up here. Come on. Quick. Say it again. You get to be a speaker for the day.
Thank you. Electromechanical, pneumatic, and DDC.
Is that correct? Yes? All right, come here. No. You get a chocolate bar. I want to be like Oprah, and you all get it. No, you don't. Okay. Where'd I put this thing? Okay, a BAS has 4 parts. That is principle number 2. So what are the 4 parts of a BAS? Servers, supervisory devices, field controllers and trunks, and inputs and outputs. So here's a cool, real quick warning that my daughter insisted I put in here because she said my drawing that you're about to see is really bad. So this is a warning, public advisory. I am not an artist. I'm a building automation trainer. Okay, so this is your 4-layer architecture. You have the server layer, supervisory layer, field controller layer, and sensor layer. And this may correspond with something that's on that paper right there. Now, the parts and pieces of a BAS fall into these layers. Servers conveniently fall in the server layer. You see, the stuff isn't that hard. They all kind of go in here. Supervisory devices go into the supervisory layer. Field controllers go into the field controller layer. And the field trunk connects the supervisory devices to the field controller. We'll talk about why in a second. And then, why is that doing that? I've got big thumbs. So the sensor layer and the inputs and outputs, they are in the same layer there. Let's go through the first thing. So building automation servers, and this is a blade server. So if you ever hear of the term rack-mounted blade server, this is what they look like. So these would go inside a rack inside the IT closet, which, by the way, I want us all to put our hands in the air again, okay? Come on. Seriously, put your hand in there. No one's going to, okay. Well, the ones of you who do have your hands in the air, which was a couple of you, I want you to make a commitment, please do this, that you will never put a server under a facility manager's desk ever again. Please. I mean, everyone talks about IT security and they're worried about BAS on their network, but then they put servers under a facility manager's desk or in the front lobby, or I saw them in the computer lab of a school. That's a great place to put one. So don't do that. Building automation servers. So servers connect multiple supervisory devices so that their point data can be monitored, controlled, and archived. Does that make sense? If it doesn't make sense, this is your time to say it doesn't make sense, and I can help you make it make sense. But if you don't say that, I can't help you. So hands, anyone not making sense for you? Okay, go ahead.
Is that referenced as the front end?
Yes, so
Is that referenced as the front end, the server?
typically that will be the front end for multi-building sites, and you'll see why when we move into the supervisory device. Because this is going to connect multiple supervisory devices so that their point data that you would view on a front end, which supervisory devices nowadays can act as front ends for small buildings. But if you wanted to go and have all of your data in one point, you would have to have a server, because otherwise you would have to log into each supervisory device individually to access that data. So you still can do that if you don't mind the extra labor, and that's a way to shave 20 to 40 grand off a job. If you want to do that, as long as you're willing to accept the fact that you're individually going to have to log into devices, you're going to have to figure out some way to collect trends and alarms and all of those fun things. The server does all that for you. Make sense? Okay. It can actually. I'm not going to go into that because that's more advanced. But yeah, there's definitely, so you'll see there's a lot of resources at the last page. Don't go to the last page right now. But there's a web link that has a ton of resources. I've written over 200 guides, 100 podcast episodes, a bunch of videos that you'll have access to after this. Because if I hear my podcast playing on one of your phones, you'll be ratted out. All right. So supervisory, but yes. Supervisory device. Supervisory devices use field trunks to connect field controllers to the BAS network so their point data can be monitored and controlled. You notice the slight difference there? Who noticed the slight difference? Let's do some compare and contrast. These are connecting supervisory devices so that their point data can be monitored, controlled, and archived. See that? Supervisory device, however, is connecting field controllers through field trunks to connect or to control and monitor the point data from the field controllers. You seeing how that's kind of building so far, everyone? Yes? No? Head nods? Yes. Okay. Layer 3, field controller and field trunks. Field controllers process data from inputs in order to control outputs to maintain a set point. Field controllers can do a lot of stuff. They can do analytics these days. They can do scheduling. You can do all these things. But at the core of it, if they fail in this one thing, all of that stuff doesn't matter. If you've got a PID loop that's out of control, and that's a way of controlling outputs. It's a control method called process integral derivative, or proportional integral derivative. But if you've got that, the programming concept that's out of control, it doesn't matter if it's scheduled on, if it's driving at 100% cooling valve and the space is 64 degrees. You can have it scheduled on all day. It's not going to do its... So that is what I mean by these things, they have a single purpose that you really got to focus in on. Now, field trunks, they allow field controllers to connect with the greater BAS network. Aha, see, remember when I told you my wife spell checks these things? Yeah, she missed that right there. She missed that extra "the." So I'm going to give her a lot of heartburn about that. Actually, she sent me the updated revised version that I may have not opened last night because I was at the Control Trend Awards, and it probably does not have the in there. So inputs and outputs. So inputs measure a specific value and provide that data to a field controller. Outputs are commanded by a field controller to maintain a specific value, and that's an actuator right there. So is this making sense so far? You all give me some feedback. Too high level, too low level?
This is really the front end, not the top.
I'm sorry?
Isn't this really the front end
What do you mean?
of data coming in?
This would be the entry point for data, yes. Okay. Yeah, so if you had, and some field controllers can do this, and I'm vendor agnostic, so I'm not going to dive into which field controller, but some field controllers can actually schedule and analyze and trend and do all of that in the field controller. So essentially, and they have graphics, so essentially you could have everything that we've went through so far sitting in a field controller except for the server. Now, I won't dive into that. That's more of advanced. Want you to have these core foundational pieces before we ever go into any advanced topics. Because if you don't have these, you can't really see and understand the use case for the other technologies. Alrighty, key point. These four parts will almost always come together the same way. So I meet a lot of folks and they're like, well, can I have a server? Do I need a server? Do I need a supervisory? I'm taking this pneumatic system and I'm going and I'm pulling it into the BAS. What parts and pieces should I use? Well, if you understand how I just built out these four layers, they're almost always going to be built the exact same way. Now, there are things like IP architectures and edge compute and things like that, but you'll learn about that on the show floor. You'll at least have the foundation for when folks start talking to you about that to really understand why that's valuable or why it may not be valuable for you in your specific situation. Now here is another quiz. I need a volunteer. Anyone? Come on, put your hands up. Or I pick people. Come on up. Okay. All right. Now this one's pretty easy. So we have server, supervisory, field controller, and input-output layer. What layer is this?
Server.
What layer is this most likely?
Supervisory.
And what layer is this?
Field control.
And then this?
Sandwich.
Sandwich. What?
No.
You failed. You get nothing.
No, sensor.
Okay, so you see how and I don't know, do you work for Automated Logic?
No.
Okay, so he does not work for Automated Logic, but he was able to understand the layers because they're almost always the same. So it's really important that when you're evaluating BAS submittals, when you're going on a job site and you're looking at existing drawings, you can look at it through this mentality and kind of understand what's there, even if you don't know that manufacturer's product. Okay, you get a chocolate bar. There you go. Okay, we've got one more, and this one's for a book. This is a little harder, and it looked a lot crisper on my laptop screen. So come on up, whoever wants to win a book. Come on down. So same thing. Take us through it. What's this?
That is our server layer.
Okay. And then where would our supervisory layer be?
Below the server layer.
Yep. And
Right here.
and how would you kind of determine that?
You can see the supervisory devices.
Good.
There.
Yep. Yep. And then field controllers would be where? I know this is hard to read.
Look, it looks like they're on the bottom
Yeah?
here.
Because we can see some inputs and outputs going on stuff, right?
Yeah, we get some actuators and drives.
And then input and output would naturally be
These are gonna be,
kind of below, right?
yeah.
So does that help? Does that help kind of make this a little less mysterious? Just a little bit less mysterious? Yes? Seeing head nods? Good. Come here, buddy.
Thank you.
Thank you. I want you all to come out of this feeling comfortable and embracing these three principles, because if you do, everything else you're going to see on the show floor is going to have context. And that context is really going to make the difference between you being able to understand if this is a technology I can apply to my business, or I can go and learn and be a better tech or a better salesperson, and not understanding what that technology can do for you. Okay. Principle number 3. A BAS uses each part uniquely. Now, there are many reasons for each piece of a building automation system, but there's almost always one or two reasons that are going to be most important. Remember how I talked through with a field controller, if it doesn't properly process inputs and outputs, it doesn't matter if the schedule's on. It doesn't matter if it's giving you graphics out of that field controller if it can't read the input. So servers. This is a workstation server. Now, what did we, and by we it seemed like it was just me agreeing, but what did we agree that we're not going to put under desks anymore? These things right here, right? These workstation servers. So that's a big security no-no because it has these USB drives in front, and that's where disgruntled employees and hackers can just put malware and take over your BAS network and do all sorts of fun stuff for Bitcoin. All right, so building automation servers. The main reasons we have these: to combine multiple supervisory devices into a single user interface. That's the main reason for a server. Okay? There's analytics software out there that can pull directly from a supervisory device. It's not going to necessarily need a server to do analytics. So sometimes you'll hear folks say, well, you need a server to do analytics. Well, in most cases you don't. But if you want to pull multiple supervisory devices together, you're going to need a server. Whether it's cloud server, physical server, hybrid server, doesn't really matter. You need a server. Second thing, they provide a single point of collection and storage for all point data. You should always be trending. You never know when you're going to need that data later to prove that you should replace a chiller, or to prove that you need to upgrade, or to prove that you've been doing your job because you're getting audited by Joint Commission because someone got an infectious event in an OR. You never know when you're going to need data. Should always be trending. But if you try to trend into a supervisory device, which has about the storage capacity of my son's Nintendo, what is that, Switch I think he got this Christmas, then you're not going to have a lot of storage capacity. So you want to have a server to store all that data. So those are the two main reasons for servers. Make sense? You have a question? Yeah, sure. So I go to a commercial office building. It has a 40-ton packaged rooftop and 20 VAVs. It would be perfectly fine with, honestly, with some of the hybrid supervisory devices that act both as a supervisory device but also a field controller. That would be a great time when you would just simply need that supervisory device. Now let's say you're a property management firm and you've got 20 of those buildings, and you have a centralized maintenance strategy where you then want to manage and dispatch to your contracted maintenance team. You would then go have a server where you can see all that data from a centralized point. Does that make sense? Now the gray area is where you have maybe 2 or 3 buildings, and it's kind of like, hey, how do I go, and do I have a server? Do I not have a server? you've got to ask yourself, how do you use the system on a day-to-day basis? And that will kind of dictate whether you go and want to invest in a server because you're heavily involved, you're using graphics all the time, probably makes sense. You're someone who everything's outsourced and you're really just a janitor who's maintaining and turning on and off a light switch, kind of probably don't need a server. Make sense? Okay. Let me just see what time we're at real quick. Oh, wow, we got plenty of time. That's awesome. No one ever complained for finishing early. Supervisory device. The main reasons, or reason, to collect data from multiple field controllers into a single device that allows the operator to monitor and control field conditions. That's your supervisory device right there. If the server fails and you lose connectivity, you should be able to go to the supervisory device and control that building. I've seen a lot of times where wide area networks went down, ISPs, internet service providers, they drilled through the ground and next thing you know, the fiber line's gone and your buildings don't have connectivity. But if you have a supervisory device, you can log into that and you can go and control your conditions. Make sense? All right. Field controller and field trunks. The main reasons for these are to process inputs and outputs. So we want to take our inputs, our temperatures, our pressures, our alarms, and then make a code decision that then drives an output. Field trunks exist to allow field controllers to communicate with the supervisory device and other field controllers. Now I'm going to go back several slides, and we're going to kind of just look at that real quick. Give me 1 second. I'm going to have a sip of water. Okay. So right here, I like this graphic because I can see this, you can't, but it says router. And that's really it, the scheme of things, that's what supervisory devices are. They started as essentially routers. Basically, you have a field level network, a serial network. And that's not cereal that you eat, it's serial, I'm going to try to spell here, S-E-R-I-A-L. Does that sound right? Okay, good. So serial networks communicate data one after another. So it's in series. That's why we call them serial networks. Well, serial networks, what they do is they daisy chain from controller to controller to controller. That's MSTP, Master Slave Token Passing Backnet. And essentially it has a trunk that allows these data points to communicate, but it's a serial network. Can't communicate IP because it's not an IP network. It's a completely different network type. So supervisory devices initially came about to go and take that serial data and communicate it at IP or Ethernet layers. And so they would convert the data. And someone much smarter than I figured that they could put user interfaces in there and they could actually give you the capability to command and control. And thus you have command and control capabilities in supervisory devices. That's just a little historical tidbit. Okay. It says 50 feet, but apparently it can't travel through me. All right, inputs and outputs. Inputs. Yeah, of course. A trunk? So a trunk is another way of, do you know what a bus is? Field bus? So here, we're gonna do something really cool that is like presentation no-no. But I can do things like this because I'm the presenter and I realized how much we're under time. Isn't this cool? So here's your supervisory device, right? And then essentially what happens is you've got field controllers This is the worst daisy chain I've ever drawn in my entire life. But what happens is these daisy controllers are connected by a multi-wire cable, and that is often known as the trunk. Now see, in IT world, and if you've got an IT background, this can confuse a lot of people because in the IT world, trunks connect switches and connect routers. Basically, they are a dedicated connection between two networking devices. So there's two definitions of trunks, and you got to be really careful when you go and you talk to IT people and you're talking about your field trunk, because they'll think you're talking about a actual trunk between two networking devices when you're actually talking about your MSTP trunk. And that's a whole nother topic about communicating with IT and the confusion that comes because we use the same terms, but we use them differently. So, but much more than you probably wanted to know. Did that answer your question though? Yes? Okay. No worries. That was really cool. I like that laptop. I can do cool stuff like that. All right. So, inputs and outputs. Main reasons. Inputs exist to measure a specific value. Measure temperature, pressure, all those kind of things. Outputs exist to control a single device. Control actuators, control relays, send an output to a VFD. Those are inputs and outputs. So where do we go from here? We're going to have some time for question and answer. I wanted to leave a lot of time for questions, so we're going to have that. But what we can do from here are three things. Now I'm going to ask that you don't do item number 2, I believe, until after this. But first we can review what we've learned today and consider how it applies to your day-to-day job. I want you to think through what you've learned today, and I want you to consider, how does this apply? If I'm a designer, how would this apply to my designs? Might I put more focus on servers? Might I put more focus on creating a graphics standards for my customer, knowing that if they want a building automation system specifying 10 pages of temperature sensors is maybe not, I mean, sure, it's easy to do, but it might not be the best value for the customer. Go to the link provided at the last page of your workbook and dive deeper. There's almost a year's worth of content on that webpage that I'm giving you. I mean, over 200 hours of podcasts, guides upon guides, all sorts of stuff you can access there. So you'll enjoy that. It'll be fun. You can download the presentation and the workbook. I just ask that if you go give paid keynotes that you make sure that you say, hey, it was created by Phil Zito, not you. So please, thank you. And the third is pursuing formal training on building automation. Now, I do provide training on building automation. It's not why I'm here to talk to you today, but there are multiple sources to pursue formal training on building automation. You really should do that if this is a career for you. Now it is time for questions, and we've tested that everyone's hand works, so we know that. And I've also got a public service announcement for you. So any of Lord of the Rings fans, one knows that one simply does not wander into Mordor, nor does one simply have no questions for the question and answer section. Okay, yes, he did, but he's come back to life through the power of Canva graphical editor. So he's come back. For you, he's come back from the dead for this one brief moment in time. Oh, thanks, man. Appreciate it. So let's start with questions. Hands. Okay, first question.
So in your brand agnostic opinion, do you see the lines blurring with the supervisors and the servers? Leave joint commission out of this. I'm not talking about citing historical data for 7 years. What I am saying is memory prices are dropping.
Pick up your microphone.
They are packing the supervisors full of memory. They've got USB devices that we can plug in. I mean, it's 128 gigs on the side of it. And they have supervisory functions and they have server functions. They can do analytics. So do you see those lines blurring?
Yeah, great question. So I mentioned that there's other architectures, and one of those architectures is the 3-tier architecture, or as I like to call it, the collapsed core kind of IT concept. And essentially, you collapse the server and the supervisory device into the server. So I'm seeing that where the field controllers, especially with IP field controllers, can go directly to servers, because that supervisory device originally was a protocol gateway. You don't need a protocol gateway if everything's IP now. That's the big benefit of IP. I used to not be sold on IP. What is the point? I mean, is it just for someone to sell more ports and switches? But I'm actually seeing that there's a lot of benefits of having a flat IP architecture from protocols. So specific, I see supervisory device capabilities going into field controllers. I also see more cloud hosting like Codora, which is a outsourced cloud hosting for Tritium web supervisors. And you're seeing stuff like that pop up. So you can go and do cloud hosting and then have IP controls, if they support it, go directly into the server. That's kind of where I see things going, because I don't really see the point for protocol gateways if everything can speak IP. Make sense? Who else? All right, come on. Here we go, pass it down.
Thank you. Along the same lines, do you see IP moving deeper into even the realm of inputs and outputs and eliminating these other classes altogether?
So with IP controls, you'll have trunks gone. So IP at the I/O level. The thing is, how many of you have installed controls? Okay, a couple of you, cool. In most cases, it's what, a 4-foot run from the sense device to the controller? To run Cat5 and just the cost of that, plus then now you have to administer IP address distribution and routing and switching through your device. That's why I don't see necessarily I/O going IP anytime soon, with a caveat. I'm really impressed by the Belimo offering, their IoT actuator offering. It looks really promising in that it takes delta T, basically supply and return and flow, and the actuator, and pulls all that into the cloud and then does analytics, because valve control is one of the really big issues at a lot of buildings. So those kind of micro solutions that use IP, I find those to be very promising. But going and using sensors that are IP, I don't see the value prop yet. Make sense? Who else? Alrighty, get my exercise. There you go.
Is the limiting factor for the number of field controllers and supervisory device the type of network?
Yeah. In some cases, yes, and in some cases, no. So field controllers on BACnet MSTP networks, those tend to be about 100 devices a segment. And that's because there's voltage drop every time that voltage is repeated from one controller to another. You don't necessarily have that with Ethernet and IP. And so if you have IP controls, your limitation tends to be this concept called your broadcast domain. And essentially how networks work is they send out a message to everyone on what's called a subnet. It's a sub portion of a network. They send out a message saying, hey, I'm here, and everyone on the network replies to the switch. Now, if you extend that sub-network to be 500, 1,000 devices, it gets really chatty, really hard to troubleshoot, really hard to work with. And so in that case, IP tends to be limited by the protocol, whereas trunks, field trunks like LAN, FT10, MSTP, BACnet, they tend to be limited by wiring and electrical signals. Does that make sense? Awesome. Who else? Another hand. Awesome. And there is still one more question that I'm going to ask you all.
Is there ever a scenario where you don't need either a server or a supervisor there, where the controller is doing all your calculations?
Yeah. Well, yeah. I mean, people who sell you BAS probably don't want you to think that, but yeah, I mean, quite honestly, you could go and get a field controller that has a display on it and put it in a small school boiler room and control the hot water right there and just have someone come in and change the set point. The thing is, you always have to balance. There's so many factors, right? And it's not just a technology factor. You have to balance the technical skill set. Can that person go and use that display? I mean, I remember this call that I got where the guy kept saying, the BAS says 60 hertz. And I said, well, what have you done? He said, well, I reset it and it still says 60 hertz. So, okay, well, read me the rest of what it says. And he's like, display settings and da-da-da. I'm like, do me a favor, turn off your monitor and turn it back on. And he was in monitor configuration mode, and that's why it said 60 hertz. So you've got to understand the level of your user. Some users can use those displays. Some users, they need that BAS interface. So it's not you're avoiding costs, but then you're inducing trouble calls and paying, $140 an hour for 3-hour minimum for someone to come out there and work on something that could be resolved in 5 minutes. Does that make sense? So yes, you can do it. In most cases, the supervisory device, if you have more than 10, 20 field controllers, it just makes sense. Get a supervisory device that acts as a field controller, put it on your central plant, you pay maybe about $800 more, and you've got a supervisory device. Yep. I think your hand went up first, and then I'll get you.
My question is, your podcasts, how are they structured, and how are they structured? Can I just go in and pick which topics I'd like to learn, or is it something that you start from the beginning?
Yeah. So you should never listen to episode 1 or 2 or 3. Just they don't exist, even though they do. You just go on iTunes, and they're structured. Now that I'm not doing it as a hobby, they're actually structured. Before, it was just whatever was on Phil's mind that week. And so they're just listed out as topics, and you can go. But now they're much more structured in themes, in sections, where I'll spend a couple weeks on IT, spend a couple weeks on design, spend a couple weeks on different concepts. And so there are a series of gradually escalating kind of complexity and depth. And you just go on iTunes, Stitcher, pick out which one you want to listen to. It's all there. Good question.
How many devices nowadays go through an internal troubleshooting testing type protocol on a certain basis in order to raise any red flags that there's problems with either the device or with the network?
Ooh, that's a good one. Okay, so let's first talk through that kind of process. So you've got a couple different things that you can do for internal test. You've got the hardware's internal test capabilities, which that's manufacturer specific. I wouldn't even attempt to answer that. But most of them have some sort of boot up process where they'll trigger an error code. At least the supervisory devices, almost all of them have that. Now, as far as the software goes, most manufacturers will have trunk statistics. So for your field buses, they'll determine if you've got errors there, and they'll have statistics on the operation of the device. Those are all capabilities that a manufacturer can easily answer that question for you. You just go and say, hey, what kind of error reporting do you provide both on your user interface, your hardware, and your software? And they should be able to provide that. You just need to clarify that you're not looking for alarming, you're actually looking for device error code reporting, because the initial answer will probably be, we do alarming and we can send that via email, SMTP, etc. You got more? Is that, okay, here you go. I should probably just stand by you. I can tell my wife I worked out today.
Do any of the devices use similar protocol like IP network networks where it's gonna
Mhm.
do that built-in polling of the devices.
So you're talking SNMP?
Yeah.
Yeah. So once again, things like that are dependent on the actual device, but most of them that I've run into support SNMP at least at protocol level 1, which is the unauthenticated version of SNMP. It's hit or miss if they support 2 or 3, which is the authenticated version of SNMP. Yep. Who else while I'm down here? Awesome. Pass it down, please. How are we doing on time?
With landmark buildings, you can't do too much damage on the building, so you see a problem with making everything 100% wireless?
Yeah, that's a good question. So I always hesitate when anyone says we're going to do 100% anything. Because one of the things we have in our industry is we have a huge problem with these archaic buildings where it's almost a badge of honor that we don't upgrade our building automation systems. It's like, mine BAS is on the Commodore 64, ha ha ha. And it's like, okay, all right, that's great. So as long as we have that, you're going to have systems that simply can't support those architectures. Then on the flip side, I remember I was involved in wireless controls very early on, and you have to have the design expertise to lay out a wireless. You can't just put in access points and call it a day. You have to understand the signal strength. Am I trying to communicate through solid metal walls? Is there an MRI machine right next to my wireless sensor and I'm going to get 3,000 degrees Kelvin every time the MRI machine turns on? So you've got to understand these things. And so for that reason, I think we'll always have a hybrid. Now, I do think in cases like auditoriums, a place like this is a great opportunity for wireless. Great line of sight, not a lot of interference. This would be, and I guarantee the plenum is probably wide open up here. So this would be a great wireless installation. And so you got to just look at it from that perspective. What is the building? What is the user type? Are these users who can support wireless? Because there's that aspect as well. Does that help? Awesome. Okay, and you said it's 55 or 50? Okay. I'm going to ask one more question. Oh, we do.
Just to follow up on that question, so at the input-output layer, what's your opinion of the use of wireless for, what applications would you see?
Okay. So I always say that I never say 100% on something. I just, for the life of me, I don't see why we would want to use wireless for inputs and outputs. It just seems to me, and maybe it's the old tech in me, that that's just a recipe for disaster. I mean, we run some wires, we put them in EMT if we have to, but at least I can always put my multimeter on those wires. I can always know what's going on. There's just so many variables with wireless. And when I'm talking about input and output, I may have 20 or 30 inputs and outputs on a field controller. It's a little different when it's wireless from the field controller to the supervisory device. So that's almost point to point. That's a lot easier to troubleshoot in my opinion. Now with that being said, I've used microwave to go between sensors that were on a really geographically dispersed like farms where they have a building way out there and they want to put a sensor in it, and I use a microwave to send it back to the field controller. That's wireless. I've used it in that, so point to point for long range runs, but if it's on a unit, I don't see the purpose of doing it on a unit. I've experienced too much problems, and it may have been my own ignorance of wireless, but I experienced too many problems with wireless sensors in the past where I spent so much time troubleshooting those where I could have simply just wired it up. I literally probably could have wired it up 8 times in the amount of time I spent troubleshooting that one sensor. That's my opinion. Yep, I'll get you.
Do you have any opinion of the convergence of building automation and physical security applications?
Oh, hi. Yes, so I didn't cover because I didn't want this to be a bio of myself. Prior to doing Building Automation Monthly, which is my business, I was the integration program manager at Johnson Controls. So I was responsible for integration, APIs, all that fun stuff. So yes, physical security, AV, there's use cases for all of those. The problem whenever we're dealing with any non-BAS system is that they tend to gravitate. Let's use lighting, for example. DALI, KNX, those are their primary protocols. Whereas BAS primary protocols are LAN and BACnet. So you have to do protocol resolution. Most BAS folks don't have a coding background. And when I say coding, I'm talking about getting in Visual Studio or getting in NetBeans and actually writing code. That's what you have to do protocol conversion. At least right now, until Node-RED and if that, then this, whatever that acronym is. Until those things really catch up, that's going to be the big barrier between those systems interfacing. Make sense? Oh, you're good? Okay. You sure? I promised you. All right. Okay, so without looking at your handout, you got to promise me you're not going to cheat. Okay, the first person who could tell me the 3 principles, you're going to win a chocolate bar and a book. So, come on. I even made them easy because they all start with ABAS. Go on. No one? Wow. Okay, well, I'll give you the first one. A BAS is not a... Okay, all right. So you only have to do 2 now. So first person to answer the next 2. Okay, go ahead.
The BAS has 4 parts.
Yes, it does.
That was the second one.
Yeah?
And the last one was every BAS has something unique, but I don't know what that is.
Yeah. Do you think that's close enough? Yeah. All right. Okay. So thank you so much for attending. I appreciate all of you taking your time. This is time that you could put somewhere else, and you put it in me. Thank you so much.
All right, folks, I hope you enjoyed that presentation as much as I did. It was really well attended. I know towards the end you can't make out all of the questions that folks were asking. That's because this was recorded with my own personal lapel mic and not with a wireless mic. Unfortunately, there was only one mic in the building. I was told there was going to be 2, but there's only one, unfortunately. But nonetheless, you can hear my answers and you can hear me address the questions. Thanks so much for listening. In next week's episode, I'm going to start unpacking a series of episodes around electrical building automation installation aspects. So I've been asked a lot about installation techniques and electrical wiring and all sorts of stuff related to that, and I'm going to be unpacking that over the next couple episodes. So once again, you can find everything I discussed at buildingautomationmonthly.com/102. Thanks a ton for being here. Take care. Continue to push yourself harder every day. Continue to grow in your knowledge, and I'll talk to you again next week.